Hello, everyone. Welcome. My name is Katie Kinstead, and I'm with the City of Burlington and the Community and Economic Development Office. We're happy that you are able to join us today for the webinar to learn a little bit more about ventilation and its importance to combat the transmission of COVID-19 and other infectious diseases. Just a brief note that the recording is in progress of this webinar today. We're doing that to be able to share the contents of the webinar for those who aren't able to join at this particular time. So within the webinar, we are going to explore what ventilation steps you can take to prepare for winter. I think ventilation is on everyone's mind as the weather's turning colder and activities are moving inside, and that just points out the importance of ensuring that there's clean and healthy indoor air, benefiting your staff, your clients, visitors, all of us really to combat this pandemic. So in our first part of the webinar today, we're going to cover how ventilation works, why it's important, and what you can do to prepare your indoor space, really anytime, but especially for winter as we spend more time indoors. We'll then transition to providing a few details about some programs that are here in Burlington that support ventilation work, including some testimonials from local organizations that have already taken steps to improve their ventilation. And finally, we'll conclude today's session with a question and answer opportunity. And here today, I'm joined by a number of colleagues, both from the city and from Burlington Electric, and from our engineering firm, CX Associates. And so some names that you'll see on the screen today and hear from include Chanel Moore. She's the city's grant coordinator who will be helping us with the logistics of this webinar, including coordinating the question and answer portion. At the conclusion, Burlington Electric's Jen Green, the Director of Sustainability, and Burlington Electric's Chris Burns, the Director of Energy Services. Both Jen and Chris have been instrumental in supporting some of the city's grant-funded initiatives that provide technical assistance and financial support for ventilation improvements. And finally, we're joined by Ava Killian, the Associate Principal at our partner engineering firm, CX Associates. In addition to those here today, I want to provide a special thanks to the funder of the city's ventilation improvement program, the Vermont Community Development Program. They awarded the city a community development block grant to provide technical assistance to organizations and also provide support such as this webinar, and then financial support for some to actually implement some of the equipment installation. And before I'll hand over to Evelyn to provide a deep dive into the science, application, and practical tips on ventilation, we wanted to share a really quick introductory video that provides about a 3-minute overview on ventilation, just to bring everybody onto the same page. And it's important to combat the transmission of COVID-19. So here we go.
Indoor ventilation during COVID-19. Meet Michelle. Michelle is a business owner who wants to protect her workers from COVID-19. Michelle knows that COVID-19 spreads through respiratory droplets and aerosols when infected people breathe, talk, sing, shout, cough, or sneeze. The risk is higher when people are in enclosed and crowded indoor spaces with poor ventilation. Ventilation can help improve indoor air quality by reducing the concentration of any potentially infectious COVID-19 droplets or aerosols in the air. This is accomplished by introducing clean outdoor air and removing stale indoor air. Ventilation can be achieved naturally by opening doors or windows to the outside, or by installing a mechanical ventilation system. The use of a portable air cleaner with high-efficiency particulate air, HEPA filters, could be considered in spaces where ventilation is poor. Portable fans circulate the air, but they do not remove contaminants from the air or improve ventilation. If using a fan, make sure it's not blowing directly from person to person. Michelle's workplace has a heating, ventilation and air conditioning HVAC system, which also filters the air. Michelle makes sure that the filters are cleaned or changed regularly according to the manufacturer's recommendations. She knows it is important to select filters that fit properly, are compatible with the ventilation system, and that have the highest MERV rating possible. In general, the higher the MERV rating, the better it is at removing small particles from the air. MERV stands for Minimum Efficiency Reporting Value. Finally, Michelle makes sure to have regular maintenance performed on the HVAC system, according to the manufacturer's instructions. Michelle also meets with an HVAC specialist to see what she can do to improve ventilation in her workplace. Michelle made sure to ask the HVAC specialist: is the HVAC system operating correctly? Is the HVAC system suitable for the type of setting and the number of workers? Can the ventilation system be adjusted to bring more outdoor fresh air into the building? Is it possible to upgrade the air filters? Ventilation should always be used with other precautions such as limiting occupancy, physical distancing, wearing masks, and frequent hand washing. It is important to use multiple practices at once, in a layered approach. Michelle will incorporate good ventilation practices along with other precautions, as part of her overall safety plan to prevent the spread of COVID-19. Indoor ventilation.
Okay, so thank you, Katie. My name is Evelyn Killian. I'm the Associate Principal at CX Associates, and we are a small engineering firm in Burlington. And we've been doing quite a bit of work since the beginning of COVID on specifically on ventilation and indoor air conditioning, indoor air quality considerations. We've done a lot of work in schools when we were trying to decide how to safely open schools from the very beginning of COVID. And now recently, from the beginning of this summer, with CEDO and Burlington Electric, specifically on small businesses and nonprofits in Burlington. And so we've looked at a lot of buildings, and I'd like to talk today about a little bit more of the technical side of ventilation and what we can do in our buildings, specifically in our Vermont type of buildings. Next slide, please. Chanel, could we have the next slide, please? Thank you. I just want to quickly mention that all of the technical side is guided by the CDC and what they know about COVID specifically. And then from ASHRAE, which is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, that set standards for ventilation independent of COVID. I mean, we need to be in ventilated buildings especially in the winter, that have mechanical ventilation so that people are comfortable, so that the air movement and the air circulation, so actually bringing in fresh air, is always part of the heating and cooling of the building, so that we stay safe from any kind of virus that is spread through people, through aerosols. So ASHRAE is an organization that sets a lot of these standards, specifically here for ventilation. And then there's also the American Society of Plumbing Engineers that sets standards. Next slide, please. So the caveat here is that we'll be talking about ventilation. Actually, if you could, yes, thank you. Both of them, thank you, that's it. So these measures that I'm going to be talking about on the ventilation do not guarantee that it will stop the spread of the virus, but it will certainly mitigate it. And I'll explain why in a minute. And then also to note that not all recommendations may be feasible for all buildings. It depends on what kind of heating and cooling system and ventilation system you have in your building. Next slide, please. So for anyone who has seen these kind of talks before, you might have seen this slide before. But this is when the pandemic first started in China. They did an analysis of a location, a restaurant, where they know that there was an outbreak. And in this building, so this is a restaurant, in this building, they had the split system heat pumps that we see quite often around here. And I have a picture of later if you're not sure what exactly that piece of equipment is. But a split system heat pump only recirculates the air. And this particular location had a heat pump that went across from the table C to A to B, and then got pulled back across B, A, C, back to the heat pump. And on table A, they had a contaminated person with COVID. There was virtually no exhaust in the building and no fresh air supply. There's, as I said, one person in table A that was sick and didn't know it, and 9 people on all 3 of those tables got sick. The other tables where there was not an infected person did not have any kind of contamination. So this really proves in that one study how recirculated air and people just sitting in that recirculated air can contaminate each other. And so that is what we are trying to combat here with ventilation. Next slide. Social distancing and masks are definitely the first line of defense. The video said it very clearly, Michelle's experience in the video. And HVAC within the building is a second line of defense. So a mask and distancing will stop the large droplets and the short range airborne droplets from getting to us, but there's still the long range aerosols that are in the space, and you need to get that out of the space, and you need to introduce fresh air to keep people safe. So that is what mechanical ventilation will do for us. Next slide, please. So to determine what ventilation levels are safe and recommended, and yet not, increase the ventilation so much that your energy bills are going to go up too much. ASHRAE has established some ventilation, has established a calculation form, and that is that it determines how much outside air is required dependent on the floor area of your space and dependent on the number of occupants you have in your space, and then what type of space you have. So for example, if you are a gym, you're going to require more ventilation because people are breathing heavily and harder, and it's getting propelled faster, versus a classroom or even a theater where people are just more sedate. So what ASHRAE has is a calculation for that space type. So in this case, we've taken a classroom as an example, where for the occupants, you have a requirement of 10 cubic feet of fresh air per person. So you would multiply that 10 cubic feet per minute times the 18 occupants to get what you need for the people. And then there's also the 0.12 CFM, cubic feet per person, cubic feet per minute per square foot for the area. And in this case, for this example, we conclude that the outside air requirement is 271 cubic feet per minute. And so we recommend that you get someone, whether it's a contractor or a commissioning agent or a mechanical engineer, to calculate what your spaces need for ventilation for the number of occupants you have. Next slide, please. Then as far as controlling your ventilation, the recommendation now is, at first when COVID first hit, people were saying just ventilate 24/7. And that just increases your energy costs so much and is unnecessary. So what they're recommending now is run your ventilation a few hours before you have occupancy, ensure that it operates all the time during occupied hours, and then 2 hours after occupancy to just get things cleared out before and after, and of course during. There's many ventilation units that are the fan is controlled on temperature. So when you've hit the right heating set point or cooling set point, the fan will turn off. You want to make sure that that doesn't happen during your occupied hours. You want that fan running all the time. The other thing that they recommend is to run the bathroom exhaust fans on that same schedule so that you are always keeping the building a little bit at a negative and introducing just a little bit more ventilation through your nooks and crannies in the building. And then if you don't have ventilation, and we'll get into those details in just a minute, there's a lot of buildings in Burlington especially, but throughout Vermont that have baseboard heat and have no ventilation or air conditioning. So if you have baseboard heat, and maybe you have a heat pump for cooling, you don't have fresh air coming in, mechanical ventilation coming into the building. In the summer, opening windows is great. In the summer and in the shoulder seasons, you can use economizers to bring in more fresh air. In the winter, you'd really want a heat recovery unit, and you could, if you have no ventilation, the easiest thing is to just put in a heat recovery unit for the entire year. Next slide, please. So there are some units that you might think bring in fresh air and they don't. And so that's important to know. So the top left picture is one where there's just it's a little hard to see, sorry, where there's just a diffuser coming from the space next door. That's not fresh air. The top right is the indoor unit of a split system heat pump. That is just recirculating air. It's cooling or heating, and it does a great job at conditioning, but it does not provide fresh air. And then the bottom two, the one on the left, is just a window or a wall, through the wall air conditioner, which sometimes can have an outdoor air intake, but a lot of times is recirculated room air. And the bottom right is just a space heater, an electric space heater. So none of these bring in fresh air, and you want to make sure that that you have more than that. So what do you do if you have no ventilation air, mechanical ventilation into your building? Chanel, if we can go to the next slide. The best thing, the most energy efficient thing that you can do is to add either a heat recovery ventilator or an energy recovery ventilator. And what either of these units are is really, it's a heat exchanger. What that does is these units are relatively small, and they can fit up maybe at your ceiling level or in a closet somewhere. And they have 4 ducts, 2 on each side. And what it does is it takes in fresh air from one direction. So in this case, the top greenish blue, the aqua, the arrow going in, it's taking in the outside air from one direction, and it's taking in room air, the top right duct, taking in room air. So say that your room air is at 74 degrees and your fresh air intake is at 10 degrees. What the recovery unit will do is it will, inside the unit, have enough surface area where the two will transfer their heat. And now your exhausted air is maybe coming out, it started at 74, it's maybe coming out at 50 degrees. And the fresh air is taking that heat, and if it started at 10 or 15 degrees, it's now coming out at, say, 50 or 55 degrees. And so that's a very efficient way of bringing in fresh air, much better than just having a direct fresh air intake. And it's also much more comfortable. So for these units, you can either tie them into a ventilation unit that is just recirculating air. If you determine that your ventilation unit doesn't bring in outside air, you could tie this into the ductwork for an air conditioning unit. Or if you only have heat pumps or baseboard heat, you can put this as a separate unit all by itself. The air will be, a little tempered. It won't be very hot or very cold during heating or cooling season, but it will be comfortable and won't create drafts. You can also, the bottom picture is a through the wall unit that doesn't require any kind of ductwork. This is for very small areas. So say that you have a small office like I'm in right now. And that is a good one where it, for a certain period of time, will exhaust air only, and it will heat up that core. And then for a short period of time, it will reverse and bring in outside air and heat the outside air with that core. And there's no, as I said, there's no ductwork. It's just through the wall unit. If we can go to the next slide, Chanel. So the other thing that is really important for COVID and for viruses in general is to increase the filtration of the recirculated air. So the ventilation air here in Vermont doesn't really need a special filter. I mean, it needs, a rough filter, but it doesn't need a filter for capturing virus and particles from people, but the recirculated air definitely does. And typically an air handling unit will have a MERV 6 to 8 rating. And for viruses, they are recommending at least a MERV 13, if not higher. The problem with these higher filters is that they have a bigger pressure drop, and your air handling units might not be able to provide enough air. The fan might not be powerful enough to provide enough airflow. So it's best if your contractor and your designer put these MERV 13 filters in before you do your airflow test. And then you will be able to see how much airflow are you getting in each of the spaces, and how much is that air handling unit able to produce. And then you can decide with your contractor from there, do we need to speed up the fan? Do we need to have a separate HRV instead, or do we need some portable HEPA filters? Because the air handling unit just can't provide the amount of ventilation that the space requires. So an air handling unit, some people have recommended putting HEPA filters or UV light in a ventilation system. We are not recommending that because the maintenance on a UV light is pretty intense. There's all kinds of safety precautions you need to take when handling UV. They're also very expensive, and you have to replace them. To be effective, you have to replace them every 3 to 6 months. The HEPA filters are also not recommended for general air handling units because of their pressure drop, and fans aren't designed to handle that much pressure drop. And so you're going to cut your airflow drastically if you put a HEPA filter in there. And that it goes against what we're trying to do here. We're trying to get enough turnover to keep things moving, and a HEPA filter would be a problem for that. So we typically don't recommend putting them in air handling units, but HEPA filters and even UV light are good for standalone in special circumstances. So if you can't introduce any ventilation or enough ventilation in a conference room, for example, that has ebb and flow of people, or eye doctors and dentists where people are really very, very close, unmasked. Those are really good locations for standalone HEPA filters. Next slide, please. So in conclusion, there's really 5 steps. Thank you, Chanel. So you can, the 5 things you should do in your buildings. Start by making sure that all the equipment works. If you have a ventilation, if you have an air handling unit that has outside air, make sure that the damper opens, and make sure that the fan works, and make sure that the temperature sensors work, so that you know what you have. If the air handling unit that you have has recirculated air, especially only, but in any case, you want to filter the recirculated air. So that means putting in a MERV 13 filter. And once you have those 2 things established, ask a mechanical contractor or a commissioning agent to conduct an airflow test to see how much ventilation air do you have already, and be able to have that person calculate how much ventilation does each one of your spaces need. If there's no existing ventilation, install an HRV, heat recovery unit, or an energy recovery unit in your space. And as a last resort, install portable HEPA filters for places that are small and people congregate closely. And last slide, Chanel. We at CX, so we at CX, my coworker Katie Mason and I have been doing this for now a year and a half. So if you have any questions at all after this presentation, or after the Q&A session of this webinar, by all means, feel free to reach out to us. Thank you. I'm sorry, I should be the one to introduce Chris Burns. So Chris Burns has just unmuted himself, and we can see him now. Chris is the director of Burlington Electric Department's Energy Services, and he will talk to us about on-bill financing and options given by BED. Thank you.
Good afternoon. Thank you, Evelyn. That was really helpful information. So quickly, I was asked to describe our on-bill financing option. And what we have is about $500,000 available for various upgrades for business customers. And the repayment is done on your monthly electric bill, 0% interest, and loans can be 12 to 84 months, and there's no money down. We give you the money to pay your contractor. All the work that Evelyn described including the engineering work. We're finding that that's an issue for folks. It's where do you start? And you need some professional guidance to tackle some of the issues in your building. So we can fold that into the loan. The primary goal is building ventilation, and whether that's new equipment, controls, engineering, we can talk to you about any of that. We also offer it for critical equipment replacement, where some piece of equipment, let's say in a restaurant, has failed and it's really affecting productivity and profitability. So can we help there? Building facade alterations as well. We know of food service, again, folks were wanting to put in takeout windows and doors. So on-bill financing is available for all of that. But in terms of how it relates to the ventilation discussion, what we offer is the combination with the grant that Katie described. The grant can only go so far, and we know some buildings have more complex issues. So you can combine part of the grant with on-bill financing. We can also fold in any BED or Vermont Gas energy efficiency utility incentives. So if you have a complex situation and you need a lot of pieces and parts to be able to figure it out, our job is to help you work with you and your contractor to package it so you can take advantage of all the things that have been described today. So if you want more information, you go to the Burlington Electric website. You'll see a banner on the homepage, and one of the banners that will scroll in will be on-bill financing. And you'll notice you can contact efficiency@burlingtonelectric.com, and one of our specialists will get back to you as quickly as possible if you have any questions or you want to take it to the next step. So thank you, and I think I'm giving it back to Katie.
Yes, thanks, Chris. Thanks, Evelyn, for the deep dive into some of the science and technologies around ventilation and ways that facilities can implement improvements. To give folks on this call an even better idea of what some of these improvements might look like, we put together some customer testimonials, as well as also some information. We'll see Evelyn again on this video, just to give people an idea of what these technologies might look like and where they're implemented already within facilities in Burlington. So yeah, Chanel, if you could play the video, please.
Hi, my name is Travis Poulin. I'm the Director of Chittenden Community Action, part of the Champlain Valley Office of Economic Opportunity. And right now we're upstairs on the roof of our building. I'm standing next to one of the ventilation systems, which helps provide fresh, clean air for everyone that uses the building here at 255 South Champlain Street. Our office sees, during the summer months, probably around 40 people a day, foot traffic, coming in to utilize community action services. During the winter, that number can jump up to 100 or 140 people every day as folks come in looking for assistance with fuel, utility, housing assistance, and free tax preparation services. So as we all know, during the winter, it can be very difficult to get that fresh air coming into your house. During the summer, you can open up windows, but during the winter, not such a great idea if you don't want to freeze yourself out of your house and home. So the ventilation systems are particularly important. And one of the items that we are doing to try and help make our office space welcome, inviting, and safe is to improve our ventilation systems.
Hello, I'm Sarah Adams-Collitz, and I'm the director of the Burlington Children's Space, where we are today. And we were very concerned about health and safety during COVID. So when we reopened in July of 2020, we wanted to make sure we had the safest space. What we did through the grant program was to have our whole system assessed to make sure the improvements that we had made were the right ones, and also to ensure that the system we had could handle the work we were asking it to do. So we worked with a local contractor who we already had a relationship with, and they assessed our system and made some upgrades and ensured that the filters that we had were high quality and the correct filters, and that now we have lots of fresh air coming into the building. I think that's been especially helpful to parents who really want to make sure that we're doing everything we can to keep children healthy and safe while they're here. So some of the changes we made were very easy to see. So we have HEPA filters in the classrooms. If you were here, you could see that the plants are moving around in the air that's blowing through the building. We also wanted to make sure that we would keep things at the correct temperature while we were adding all of that fresh air, and that we were doing that as efficiently as possible.
I'm Eveline Killian, and I am an architectural engineer at CX Associates, which is a small engineering firm in Burlington, Vermont. And we work with buildings to make them operate more efficiently and effectively. We've learned that in the pandemic, the thing besides masking and social distancing, which is absolutely the first line of defense, our second line of defense is ventilation in buildings. So if a building does have ventilation, like CVOEO, they have air handling units that are already bringing in fresh air, and they are mixing that fresh air with building air. The two things we need to do with those systems is calculate how much ventilation air the building needs based on the occupancy level, and then that it's filtered. If a building does not have any ventilation air, which is often the case in these small businesses in Burlington, what we do then is we design a typically small heat recovery unit that will bring in fresh air and exhaust building air. And by exhausting that building air through this heat recovery unit, you are tempering the incoming air, so you're preheating or pre-cooling it. I will say that there are times for an air handling unit that you might be increasing your energy because you're increasing the amount of air. If you add a heat recovery unit, you're also increasing your energy slightly. That is offset in the benefit that ventilation brings to the safety of the building. And also in Burlington, at least, we can be rest assured that it's 100% renewable energy in its generation.
We are so pleased to be able to participate in the ventilation system program that is improving our ventilation system and our intake and exhaust of air throughout the building. If you're curious about how to improve the ventilation space in your own home or office space, call a contractor.
Great. Well, thank you again to all the panelists that presented the information here today. And I wanted to just hand it over to Chanel, who's going to be coordinating the question and answer session. So that participants here today are able to ask questions and kind of interact with the experts here to understand what next steps might be. So over to you, Chanel.
Awesome. Thank you, Katie, and everyone who's presented so far, and everyone who's attended today. So yeah, if you have any questions at all for any of our experts, either CX Associates, Burlington Electric, or Katie from the ventilation program, feel free to either put those questions in the chat or the Q&A. And yeah, and we will take those. So our first question is, what kind of ongoing costs could occur after updating ventilation, aside from the unit cost? What other costs could be included?
Yeah, that's a good question. So the air handling unit, if you have an air handling unit, might have just ever so slightly increase, but really just a very small amount, because you're bringing in potentially more air. So a small amount of electric increase for the fan, and then if you again, depending on how much ventilation air that you're bringing in, you might have a small increase in natural gas for your heating, if you're heating that outside air. If you have a heat recovery unit, typically those units are also very, very small. So, maybe 800 watts to maybe 1.2 kilowatts. And there you're adding electricity for the entire time that your fan is running. You might increase the natural gas for heating ever so slightly, but again, the heat recovery unit will recover a lot of the heat, and so you're not seeing the entire heat load that that outside air is bringing in. So all told, you're probably adding not more than a kilowatt hour for every time the fan runs, and you're just adding a minuscule percent of added heat. So it's not very much.
Okay, and our second question, what does an airflow test or an assessment look like, and will it affect business hours?
That's also a good question. So what we do is we bring in, and I'm sorry, I don't have an example of it with me. We bring in an airflow hood, which is probably about, the hood itself is about 1.5 feet long, and we put that to any kind of, any diffuser that you have in your spaces to analyze how much airflow is already coming into the space. And then, so that's really the only work that we do in the occupied space. If we're looking at a ventilation unit, we will go to that, which could very well, and a lot of times is on the roof or in a closet. We would look and do a traverse where we would put a probe in the ductwork to see how much outside air is coming in. And we just make calculations. So that assessment, depending on the size of the building, might take an hour and can definitely be done before occupancy in the morning or after occupancy, after occupied hours. So that is not invasive. And then a mechanical contractor would come in and modulate the dampers, which is also not in the occupied space, but may need to come in to the individual rooms to set dampers differently. And again, have an airflow hood that would determine what the final airflow is through that diffuser into that room. So that would mean that the contractor would be inside a space for 10 minutes, 15 minutes to establish that. So it's not very invasive. If you don't have any ventilation system, then we would come in and we would hopefully be prepared with floor plans where we would already know what kind of ventilation you need for each of your rooms. So we would, before our site visit, we would ask you for floor plans and ask you for occupancy levels. So what is the maximum these spaces will see? And from that, we would calculate what your ventilation should look like. We would come to the site and look into each space to determine how should we bring ventilation in. Would that be with one unit and it's ducted to the various rooms? Would we have a couple of units, maybe specifically for a particularly large room that would have its own system? And where can we go to the outside wall? And that assessment, again, depends. So for a small business would take half an hour to 45 hour at the most. So we're not talking large amounts of time, and we're not talking invasive, but you do want to have somebody that has done this before, that has the tools to measure the airflow and has knowledge to calculate the amount of ventilation needed, and then has the experience with the heat recovery units to recommend an efficient unit.
Okay, great. Our next question, are there any signs to look for that I would know that my building needs increased ventilation, or how might I know, aside from just the general knowledge, that we should be increasing ventilation?
Yep. So the very first thing you would look for is, do I have any ventilation coming into the building at all? So if you only have baseboard heat or you only have a heat pump, then your answer is already clear. You don't have any ventilation coming in. If you have an air handling unit, go to your air handling unit and see, is there an outside air intake? So is there a duct that goes to your outside wall and with a louver that would bring in ventilation air? Because a lot of air handling units are 100% recirculating, and they don't have any access to the outside. Those are, well, then if you do know that there is a duct to the outside, hold a piece of paper, if you can, go outside and hold a piece of paper to that that grill when the air handling unit is on, and see if that piece of paper gets sucked onto the grill, to see if the damper is open, if if you're actually pulling in any air. Those would be, I don't know, Chris, maybe you have some other ideas. Those would be the first things that would tell you whether you have any air coming in.
No, I think you covered it really well. And at the end of the day, the description of the tools needed to measure the flow, the specialized equipment is really what you need. The other thing about leakage in buildings is it's very seasonal if it's not a balanced mechanical system, because the nooks and crannies are dependent on something driving the air across the hole. And that doesn't happen the same way every day of the year, because you need a big temperature difference and you need wind. So buildings are different, and they behave differently depending on what's going on outside. So the only way really to know is you should measure.
Yeah, definitely.
Okay, and then our last question, unless there's any more that pops into the chat. If I am interested in upgrading my ventilation, where can I find a contractor that can help me with that?
So we are fortunate, I think, in Vermont and in Burlington, that there are a number of mechanical contractors that have been doing this for a while and are good at installing equipment and speccing equipment. We don't have too many that know how or have the tools to measure the airflow. I know that Katie and Chanel with CEDO and I believe that Chris, BED has a list. Yes, BED has a list of preferred contractors that know how to do these things. So calling a mechanical contractor in the area to ask for their experience, I'd say is the first start, the first step. And then asking them if they have the equipment to do the airflow measuring, which that's a little trickier. So there are what are called test and balance contractors in the area. And I believe that BED's list of preferred contractors has them listed in this area also. They can definitely do the airflow measuring. And firms like ours, a commissioning firm that does building mechanical system and envelope commissioning, typically has this kind of equipment to do that testing and would know how to calculate ventilation amounts.
Awesome. Well, thank you for those answers. It doesn't appear that we have any other questions. I'll give it another minute in case anyone has any last thoughts. But again, that was really informative, and yeah, thank you guys.
Yeah, I'd just like to put in a plug that between BED and CETO, there's a lot of knowledge on this topic and a lot of interest in supporting small businesses in Burlington. So I would really recommend reaching out to these entities. We at CX Associates are also very happy to help in any way that we can. And, you know, the drive for this is also that we can open up our businesses and restore our economic health to Burlington and to our small businesses that have been hurting for a long time. So we like to help in any way we can to just make it safer, not only now for COVID, but increasing your ventilation in our long winter months will only keep everybody healthier at any time, COVID or not.
Great. Well, we just want to thank the presenters again and thank the participants here today. As Evelyn mentioned, there's a lot of resources out there. First, starting with your existing HVAC contractor, as well as reaching out to the city through the Resource and Recovery Center to understand some of the programs available. Or if you are already interested, we encourage you to reach out to Burlington Electric about the on-bill financing. And we just want to, again, thank CX Associates for their partnership and really helping to provide cutting edge science really in terms of implementation in Burlington and making our indoor air safer. So thanks again to everyone. And hopefully these improvements will help to keep us all safe throughout the winter. So thanks for your time, and that will conclude our webinar.
Thank you.
Thank you.